Hello, everyone. How's everyone doing? This is Dr. Cisse, and I hope everyone is doing great. I hope you guys are doing excellent. Okay. Listen, I'm not going to be here today. Physically, I'm not going to be there, but on camera and on video, well, I'm going to be there. All right. So teaching and learning continues as usual. You should have already picked up your worksheet from the front of the room. So this lesson is all going to be about the worksheet. So there's no copying from the board or copying from the whiteboard. So all the notes that I'm giving you are going to come directly from the video. So which means you're going to fill in your worksheets, and these worksheets must be turned into your substitute at the end of the period. If you fail, repeat. If you fail to turn in your worksheet, guess what? I want you to pat yourself in the back because you already earned yourself a 0. Is that really what you want? I hope not. So please pay careful attention to the video, okay? All right. Last week we started talking about organic compounds. So we're going to continue talking about organic compound just the last week for actually talking about organic compound, okay? And let us briefly review. Everyone already know what a cell is. Come on now. What's a cell? Yeah, I heard some of you say cell. All living things have cells. Yes, that's one of the main difference between living and non-living things. All living things, everything. If you have cell, you are alive. If you have cell, you must have been living before. Okay, so all living things started out with a cell. Okay, all right. So why are cells so important to living things? Listen carefully. That's question number 1. Why are cells important to living things? Number 1, cells are important to living things because they give you your structure and they give you your function. Repeat. Cells are important to all living things, not some living things, not the few living things, but to all living things. Why? Because cells give all living things, listen very carefully, cell give all living things their structure and give all living things their function. What's an example of their function? Well, right now I'm waving my hand back and forth and I'm talking to you. I can even get up and move around. Guess what? All of that is possible because it started out with a cell. Okay? Structure. Your bone is your structure. So what makes it possible for your bone to be shaped the way it is? Because of cell. So again, repeat. Cells are important because of 2 main reasons. Number 1, they give you a structure and they give you a function. Okay? All right. So we know that cells are important because they give you a structure and they give you a function. Very important. But there must be something taking place inside the cell in order to make it possible for your structure and for your function. Let me repeat. I just said cell gives you your what? And your what? Very good. Let's say it again. Cells gives you your what? And your what? You get it. Cells gives you your structure and your function. However, listen carefully, listen. For cells to give you your structure, for cells to give you your function, there must be something taking place inside the cell or around the cell for it to do so. The cell has to do some work in order for it to do so. One of that important work that takes place inside the cell are biochemical reactions. That's question number 2. Question number 2 asks you, says, what's one of the most important functions that's taking place inside the cell? Biochemical reactions. BIOCHEMICAL reactions. Biochemical reactions are taking place inside the cell in order to make it possible to give you your structure and to give you your function. Biochemical reaction takes place among many of the molecules inside the cell or outside the cell. Okay, let me ask you a question. How many of you still remembered the four major organic molecules? Ah, that's right. I can hear you guys screaming them out. That's why you guys did so very well on the test. All right. If I can, I'm not there physically, but I can hear some of you say carbohydrate, protein, lipids, nucleic acid. Exactly right. Let me ask you a question. Are these four that we just labeled or named, are they large or are they small? Yeah, they are large. What's another name for large? You got it. Polymer. So large means polymer or big. Guess what? Those large molecules can never, 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 I repeat, let me stress again, those big molecules, carbohydrate, lipids, nucleic acid, and a protein will never, never enter a cell unless they are broken down. They have to be broken down. You know what process breaks them down? Biochemical reactions break them down. Let me repeat. The light molecules, we need them. Carbohydrate is food. Okay? Your cell have to have food. They have to eat. Okay? You have to feed your cell. Anytime you put food in your mouth, what you're actually doing is you feeding the cell. Okay? But however, the large carbohydrate cannot get inside your cell. They have to be broken down to smaller pieces. And the process by which the large carbohydrate or polymers are broken down to small pieces, which are also called monomers, is by a process called biochemical reactions. Okay, so that's how they can get inside the cell. So, what are some examples of biochemical reactions that are taking place in order to feed your cell? In order for these organic molecules to get inside your cell, what are some examples? We already talked about one. What's the process called? You break large molecules to small molecules. Some of you say hydrolysis. Yes, right, hydrolysis. Oh yeah, digestion. Yeah. Oh, you guys are smart. Hydration. All of that is biochemical reaction because you're taking something that's large, such as protein. You are breaking it down into smaller pieces by digestion. Like, for instance, when you take meat or when you take fish and you put it in your mouth and start chewing, digestion is taking place. And why is digestion important? It's taking large organic molecule and breaking it down into small organic molecule. So this way they can enter the cell. So yeah, digestion, hydrolysis, hydration are three examples of biochemical reactions. Okay. Another example of biochemical reaction is respiration. Respiration simply means that now the energy that's inside the food, we're going to get it out. Let me repeat. The energy inside food, we're going to what? We're going to get it out. And the process that breaks that glucose and get that energy out is called respiration. So this is question, I believe, number 3 or number 2. Okay? And that question simply asks you, what are some examples of biochemical reactions? 1, digestion, hydration, hydrolysis. All of that, we'll group them as 1. The next one is respiration. What's respiration doing? Is taking glucose, break it apart, and get energy out of it. And that energy is called ATP. You need to know that. That's question number, again, I'm not sure what question, but just scan through your worksheet and you should be able to find the question I'm talking about. Okay? Respiration is another biochemical reaction, but what does it do? It takes glucose, breaks it down, and gets ATP, all capital letters, ATP, out of glucose, and that's the energy I'm using right now to move my hands and to talk to you. Okay? Another example of biochemical reaction that is taking place inside the cell, beside digestion and beside respiration, photosynthesis, mostly for plants. Photosynthesis also taking place inside a cell. But then instead of breaking, they are combining. They're combining carbon dioxide, they're combining water, and they're making things like glucose. Okay? All right. Now listen me out. Listen me out. Why do you think biochemical reaction is important? Somebody talk to me. Mr. or Mrs. Substitute, please make sure they are interactive. Try to avoid unnecessary talking as much as possible. Get them engaged with this lesson. So ask a question. Why do you think biochemical reaction in cells are important? Are you ready? Number one, they make you grow. Number two, they make you adapt. Number three, they can help you reproduce. And of course, number four, they give you energy. There are many, many others, but those are the only four I want you to remember. I believe that's question number five, okay? What is it that biochemical reactions allow you to do? They can allow you to grow. Growing means you're adding more cells. You started out with two cells, one from your mom, one from your dad. That's the sperm and the egg. One from your mom, one from your dad. Now you got trillions and trillions of cells. How is that possible? Because they're dividing, continuously dividing and adding and adding and adding to make you grow. Okay? Two, they make you reproduce. And of course, three, they make you adapt and also to make you develop. So make sure you know this. Let me go through this again because I don't want to go too fast. I want to make sure everyone is getting the note, not only getting the note, but understanding. So now we're talking about why biochemical reactions are important. What is it they allow you to do? One, they will allow you to grow. Two, they will allow you to reproduce. Three, they will allow you to adapt. And four, they will allow you to develop. I believe that's question number four, question number five. Okay. All right. So chemical reactions, biochemical reactions, we talk about that their main goal is to make and break. That's a nice sound, actually. Make and break. Come on now. Make and break. Come on. Make and yeah, biochemical reaction. They make and break. They make and break. They make and break. Example: photosynthesis is making. Combine carbon dioxide and water to make glucose. They make it. Respiration is breaking. Taking glucose, combine it with oxygen, and breaks it to give you ATP. All right? Okay, good, good. So far, let's stop right there for just a minute. Let's review. Question number one was what is a cell? Everyone should know about cell. Question number two, what are the two important, there are a lot of functions of cells, don't get me wrong, but two of the important functions that I want you to know is cell gives you a structure and your function. That's question number two. You need to structure and function. And question number three is what are some of the, what is that reaction taking place inside the cell called? You got it. It's a biochemical reaction. Give me an example of a biochemical reaction. I think we discussed about 4 or 5. Digestion is one. Respiration is another one. Photosynthesis is another one. Hydration, hydrolysis. All these are examples of biochemical reactions that are taking place inside your cell. And the next question was, I believe question 5 or so, what does biochemical reaction allow you to do? And remember that? Biochemical reaction, what does it allow you to do? Yeah, that's great. Helps you to grow. Oh, boy, you guys, you're killing me, guys. Great. That's right. Helps you to reproduce. And of course, it helps you to develop and helps you to adapt. Okay, now here we go. Here we go. one of the most important chemicals in the body, one of the most important organic molecule in the body are enzymes. So please, 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 I want everyone give me your undivided attention. Again, Mr. and Mrs. Substitute, please, no laying of head on the desk. If anyone lays their head on the desk, let me know. Give me their name. And when I show up on Tuesday, hey, I have no choice but to send them to ISS. Okay? If you write their name and you tell me that they're not doing their work, they're supposed to do their work, they're in class. If they fail to do their work, write me their names and I will send them to ISS on Tuesday when I get there. So everyone needs to be involved in this lesson plan. So now what are we going to learn about? We're going to learn about a very important organic molecule in the body. There are all types of organic molecules in the body, and please hear me out. All of them are important. All of them are important. Okay, but one of the most important organic molecules you will find in the body. Now we're going to talk about our proteins. Proteins are very important. They're everywhere in your body, and proteins have so many different type of shapes, so many different. Okay, does anyone remember what proteins are made up of? If I ask you to go to the store to buy me parts that I can make a protein, what parts would you buy from the store? That's right, amino acid. Do you know how many choices you have? I mean, you go to, for instance, Aristida, and you're looking for some parts to buy to build a protein. What are your options? How many options do you have? How many of these amino acid do you think would be on the sheet? You are right. 20 different amino acid. 20. By the way, how many of you know how many letters are there in the alphabet? How many letters are there in the alphabet? Yeah. No, not 25. No, 26. How many words can you make from those 26 letters? Lots of words. We have 20 amino acid. How many protein can you make from it? A lot. You got me? All the words that you see in the dictionary, they're all the same? No, different. So guess what? All the proteins are also different. Why are they different? Because they're made up of different amino acid. Let's repeat that again. Let's try that again. Alphabet. If you go look in the dictionary, all the words in the dictionary are the same or are they different? Are there several different types of words in the dictionary? Okay, amino acid. How many amino acids are there? 20. Now, how many proteins can you make from 20 amino acids? Think about it. If you can have 26 alphabet to make a whole lot of words, guess what? You can make a whole lot of protein also from amino acid. Get me? A whole lot. Proteins are important. When you cut yourself, the healing process that takes place are protein. When you are sick, all right, and you fight an infection, you have in you what they call white blood cells. They are proteins. When you take oxygen, when you breathe in oxygen, it goes to your lung, but your toe needs the oxygen, your head needs the oxygen. The part of the cell that carries that oxygen from your lungs to your head, a protein called hemoglobin. Okay? I'm moving my arm. The reason why my arm is able to contract so I can move it is because of protein. Guys, I'm just going to list 4 or 5, which are already listed of functions of protein. But there are different types of protein. A whole lot. Can anyone tell me why there are so many different types of protein? Yes, because you have different amino acid that we can use to make different types of protein. Okay? All right. We know there are different types of protein. I believe there's question number 7 or 6, but scan through your worksheet. You should be able to tell. Mr. and Mrs. Substitute will also stop the video from time after time, so this way everyone can get the notes. Again, like I said, several different types of proteins in our bodies. One important protein that everyone must know, that the state says you have to know, that protein is called enzymes. Yes, enzymes are protein. Question, critical thinking. If enzymes are protein, then what are enzymes made up of? Yeah, amino acid. All right. Anything that is a protein made up of enzyme. Guess what? Hemoglobin is a protein, so it's made up of. Everyone say it. Let's try it again. Protein. Hemoglobin is a protein, so it's made up of enzymes. Okay, let's try it again. Hemoglobin is a protein, so it's made up of amino acid. Enzyme is a protein, so made up of amino acid. White blood cell is a protein, so made up of enzymes. All right, I like that song. Okay, the last one. Last one, please. I want you to say it as loud as you can, okay? You ready? Enzymes are protein. So they're made up of, everyone say, bingo, amino acid. Exactly right. So now we're going to learn about enzyme, okay? So what's the first thing we need to learn about enzyme? Number one, every single chemical reaction. I'm pausing so you can listen. Let me repeat. Every single chemical reaction taking place in your body involves enzymes. That's right. That's right. Every chemical reaction, biochemical reaction taking place inside your body, inside cell, involves enzymes. So who are they? Why are enzymes so important? Why are they everywhere? All right, let's talk about it. First, let's look at the characteristic of enzymes. One, we said it over and over. Okay, one important characteristic of enzyme is they are protein, so they're made up of enzyme. I guess we've said it over and over, so everyone should be able to know that by now. Enzymes are protein, therefore they're made up of amino acid. Two, this is question number 8 or so. Question number 2. I'm sorry, not question number 2. Factor number 2. Why enzymes are number 2? They act as catalyst. Let me repeat. Enzymes act as catalyst. CATALYST. Enzymes act as catalyst. Some of it is the first time you heard of the word catalyst, so I'm not going to leave you hanging. Okay? It's not just taking notes that matter, it's understanding the notes. And the way you understand the notes is by listening. Okay? So what are catalysts? Okay, catalysts, what we mean by catalyst is that they alter the rate of chemical reaction. You know what alter means, right? Change. They change the rate of chemical reaction. Who said there's chemical reaction taking place in your body? As I'm talking to you right now, is chemical reaction taking place in my body? As you listen to me right now, chemical reaction is taking place in your body. So what do enzymes do? They alter that rate. Most of the time, you know what they do? They speed up the chemical reaction. Speed it up. Okay? So don't forget that. Number 1, enzymes are protein. Number 2, enzymes are catalyst. CATALYST. That's number 2. Number 3. My hand is right here. So look, watch me, watch very carefully. Okay, look at my hand. My hand is right here. For my hand to go from here to here, I have to use energy to do that. Otherwise, it will not move. So my hand is right here. If I do this, It means I have to use some type or some form of energy to move it from this position to that position. That energy that is used in this case is called activation energy. You're activating energy for something to happen, for some type of act to be done. Everyone got me? So why am I saying all of this? The third important factor about why enzymes are important is they are involved in activation energy. Look, I can move my hand from here to here real fast, from here real fast. Okay? But I can do it from here, from this position to that position slowly. Okay, you ready? Guess what enzymes do? Enzymes lowers activation energy. That's right. That's right. Don't forget that. Enzymes lower activation energy. They can produce the same product at a lower rate. Think about it. Think. Let me give you a typical example so this way you can understand it. I want to bake a cake. Okay? You know, there is this big wedding party that is going to come up, and I've been asked to bake a cake. Not only one cake, several cakes, but guess what? I want to make several cakes within a short period of time. Okay? Now, let me ask you a question. I have two ovens. One oven, the temperature is 100 degrees. The other oven, the temperature is 50 degrees. I'm going to make a cake, but I'm producing that cake at the same time. It doesn't matter whether it's 100 or whether it's 50. Which one do you think I should utilize? The temperature for 50 degrees at the lower temperature produce the same amount, same delicious cake? Or at 100, the same cake, the same delicious cake? Which one? Why are you saying 100? Man, I'm going to sit there and wait. Temperature go from 5, from 10, from 15, 20, 30, 40, 50. I'm still waiting, no cake. 60, 70, 80, still no cake. 90, and then 100, then get a cake? Or would you prefer you go from 5, 10, 15, 20, 30, 40, 50? Bingo! Your cake! Come on now. I'm getting the same cake, the same product, the same delicious cake. One is taking a long time to get the same cake, another one taking a short time to get the same. That is what enzymes do for you. They lower the activation energy to speed up the chemical process in your body. Okay? The third one is enzymes are specific. Enzymes are specific. Now for this one here, let me see. I'm going to see if I can draw this here for you so this way you can understand it. Let me see if this camera, if I can get this camera right here. And okay, oops. Just bear with me for just a second. I'm going to get it here in a minute. Okay, I think I can get it. I'm not sure. Let me try it first, okay, guys? So just bear with me. Everyone's going to draw this. So now you need to get at least 4 colored pencils. Get your 4 colored pencils. Get your 4 colored pencils quickly. Okay, let me test this first and see if this can come to view. Okay, yeah, it can come to view. Okay, let me erase this. Okay, let me erase this. Just a minute, just a minute. Everyone, make sure you get your colored pencil. Make sure you have your colored pencil. Okay. All right, everyone ready? You should have 4 different colored pencils. To your far left, close to the margin. Far left. To follow the instruction, far left to your close to your margin. I want you to draw circles. Draw about 3 circles. Let me see. There you go. So draw about 3 circles. 1, 2, 3, and put that color pencil down. Okay. So one shape I have are circles. With one of your colored pencil, put it down. Next, I want you to draw triangles. Draw triangles with your next color pencil. Mine is blue. So I'm drawing 3 triangles. Next, if I can find my other colored pencil. Okay, here's my other colored pencil. Next, I'm going to use green. You can use any color that you prefer. Now I'm going to draw a square. So that's a square. One square, two squares, three squares. So now I have three squares. Now underneath this diagram, these different shapes that I have, I want you to write the word substrate. S-U-B-S-T-R-A-T-E. S-U-B-S-T-R-A-T-E. I don't think you can see it clearly on the video, but I'm spelling it, so you should be able to get it, okay? So there's substrate at the bottom of those diagrams. S-U-B-S-T-R-A-T-A. All right? Then put this color pencil down, get you another color pencil, and put a plus. Plus. I'm going to explain all of this. I'm not going to leave you hanging. I'm going to explain all of this so you can get it. Excuse me. Okay, now, I don't have a fourth colored pencil here, so I'm going to have to use one of those three colored pencils I use. I'm going to have to use the same color again. But you should have several different colored pencils, so go ahead and select one of your colored pencils, okay? Now, I'm going to use blue because I'm a blue man. I really love blue. So I'm going to draw what looks like look what I'm doing. It looks like a square. So it is a square. So 1, 2, 3. See that? So that's a square. Okay. Okay, let me see. Let me bring it to focus so this way you can see it. Just a second. Just a second. Just a second. Okay, there you go. All right, there you go. See what I did? All right. So let me do it again. So follow. So you draw the top, down, up, down, up, down. It's like you're drawing an inverted letter E. Okay. And then at the bottom of this, with the same colored pencil, write the word enzyme. E-N-Z-Y-M-E. So write the word enzyme at the bottom. Everyone cool? Okay, so I have, let me see if I can move this camera up a little bit. Yes, I think you can see all of them now, I think. Move it just a little bit up a little. Okay, so now, okay, it's not doing as I wanted, but I will try to explain this a whole lot better when I'm in class on Tuesday. But anyway, you have the substrate. Substrate will be like the different types of food that you eat. Okay, so one of those will be protein, one of them will be enzyme, protein, carbohydrate, and lipid. Okay, that's what those shapes stand for. The different shapes that you have that's called substrate, that'll be food. The letter E, what looks like a letter E over here, that could be your enzyme. Now look at it very carefully. Can this enzyme, can any of this substrate fit in this enzyme? And if you say yes, which one do you think will fit in it? Can all of them fit in it? Two fit in it? Or can only one fit in it? Look at it very carefully. Can all of the substrate, all of them, can they fit in this enzyme? Can two of this substrate fit in this enzyme? Or can only one fit in there? Say what? Okay, those of you that said all of them can fit in, let me ask you a question. Can this triangle fit in here perfectly? No. It's going to leave a space in between the triangle. This triangle cannot fit in. So the only substrate from these three diagrams that I have here, the only substrate that can fit in there neatly would be the square. So now I'm going to take with the same color pencil you had before, with the three diagrams that you have here, the three different shapes you have here, take the square and put it in. So that's what the square looks like. And then you color it. So you see that square can fit in there perfectly. I only drew one over here, but there's several of them. So they fit in perfectly. So only the square can fit in there. Okay? Now, once the square fits in there, now we get two things in there. We have the square, and then we have the enzyme. So draw your short arrow. Draw your short arrow. and draw the same over again. Draw the same that you had before. So draw your short arrow, like so. See the arrow? And then draw the same letter E that you had before. Okay? Now this, right, the first one that you drew, I hope everyone following, otherwise you're going to get lost. The first one that you drew, first we get the enzyme, so we call it enzyme. Now we put the substrate in there. See the green one, the substrate? So I get two parts now. Instead of one part, I get two parts. I have the substrate, then I have the enzyme. So this whole thing right here now is called the enzyme substrate. Not just enzyme anymore. Now it's called enzyme substrate. Now we call it complex. Remember, the word complex means big or large. Enzyme substrate complex. Enzyme substrate complex. Okay, so that's called the enzyme substrate complex. I know it's not that visible on the diagram, but I'm calling it out and I'm spelling it out so everyone should be able to get it. So the first word is enzyme. This is for this whole thing. This, the second diagram that you drew. Enzyme, substrate, where you color it in, that's the substrate, and complex. Complex now because it's big. It's not just one anymore. It's not just the enzyme, but now it's combined with the substrate. So we call it the enzyme substrate complex. Okay? Are there any questions? Okay, now they're going to dislodge. We got two substrates, so now they're going to combine. Okay, they were separate before, so now put your plus. Now those two substrates that we had now going to combine like so. Okay, so those two substrates now going to combine like so. Okay, so now you get the enzyme. Look what's happening. There's nothing anymore inside the enzyme. It's like clear. So the enzymes now came out from this enzyme. Now they are by themselves. Notice over here, the first diagram we have, the green circle for my diagram, the green circle was by itself. The green, not the green circle, the green square was by itself. Now the green square is combined. So which means I've made something. Okay? All right. This spot where the enzyme combines. So draw your arrow pointing down to one of these space. That space right there, draw an arrow. See what I did? Draw an arrow in that space. And that space is called active site. Active site. Active site. It's called the active site. A-C-T-I-V-E site. So that's called the active site. Okay? So that space is called the active site. Okay, you can't see it very well. I apologize for the poor visual, but I'm spelling it and I'm diagramming it and I'm also explaining it. So if you're following, you should be able to get it right. So that space that you see in the enzyme is called the active site. So the active site, this is one of the questions. I'm not sure what number 11 or so. One of the questions is asking you, what is the name of the place where the substrate fit? That's the active site. So where the substrate fit neatly, that is the active site. Okay, now, I started with enzyme, and I end up with enzyme. So one of the important things that you need to know is that enzymes are not destroyed. I want you to think about, let me come back to focus. There you go. That's a handsome teacher. Hello. Hi, everybody. Are you all doing well? You know, I'm handsome, right? Yeah. Man, what can I say? That's what my wife told me, so I believe her. Okay. All right, here we go. Here we go. Am I ready? Thank you. Thank you. Shh, shh, shh. Okay, quiet, quiet, please, quiet. Thank you. Thank you, Mr. and Mrs. Substitute for taking charge. Thank you. Okay, now here we go. I want you to figure out how or understand how enzymes work. And I'm going to explain it in terms of your lock and the key. Let me ask you a question. You have a key right now with you, some of you. That's how you get into your house. Does your key fit in every lock? I know some of you trying to be smarty pants, you're going to say, yeah, but no. If your key can fit in any lock, guess what? People be stealing left and right. So in other words, what am I saying? Your key can only fit in a certain lock. The same thing with enzymes. Enzyme will be your key, will be your lock. The substrate will be your key. Remember the small parts that you drew, the circle and the triangle and the square, those are your key. The lock will be your enzyme. The shape of the enzyme is going to determine which lock you use. For the example I will give, the shape of the enzyme, the inside or the active side looks like a square. So guess what? Only the square can fit inside that space. So what does that mean? That simply means that enzymes are specific. Okay? Enzymes are specific. All right, some of you maybe may still be struggling with this enzyme specificity and all of that. So let me try to explain again. Let's assume the three diagrams that I had: the circle, the triangle, and the square. Let's assume they're all patients. They're all sick. One of them have a lung disease, need to be operated on. Another one has a heart disease, need to be operated on. Another one has a kidney disease, it needs to be operated on. Okay? Now, my enzyme that I drew is, can that doctor, in other words, the E shape that we drew is a doctor. Can that doctor operate on all of those patients? One of those patients or two of those patients? And which one? Yeah. Notice my diagram. Let me come again to focus on my diagram. This is my diagram. This is my diagram right here. Okay? This is my diagram. This right here is the doctor. Notice how the doctor is shaped. Okay? Shaped like a square. These are the patients. These are the patients. Patient 1 is a triangle, that's a lung. Patient 2 is a circle, that's kidney, and that's the heart. So the only one this doctor right here can operate on would be this one right here, the square, because only the square can fit in there. So what am I trying to explain here is that enzymes are specific. That whatever question is, I forgot what number I'm on right now, but your teacher will stop the video so this way you can search and find the correct question. So the correct question is, enzymes, why are enzymes specific? Why are enzymes specific? Because only certain substrate can fit in the active site. Because only certain substrate can fit in the active site. That's why they are specific. Okay, are there any questions so far? Okay, let's stop right there for just a minute. Let's review. Make sure that everyone is getting it. Let's just stop right there for just a minute. Let's review. Make sure everyone is getting it. Number one, we already talked about cell. Okay, we already talked about why cells are important because of structure and function. We also said that inside the cell we have biochemical reaction taking place in the cell. I'll give you an example of some of the biochemical reactions taking place inside the cell. Then I also tell you why biochemical reactions are important to the cell? Anyone recall why biochemical processes are important in the cell? Remember we said they help you grow, they help you reproduce, they help you adapt. Okay, and next we said there are so many important chemicals in your body, so many of them. But one of the most important chemicals in your body are enzymes. What are three important factors that you can give me about enzymes? What are three important things that enzymes can do? Yes, that's right. Enzymes can lower activation energy. Don't forget it. Remember my hand? Remember my hand, right? Remember the cake scenario? All right. So yes, enzymes can lower activation energy. They're making the same product, but yeah, they lower activation energy. Okay. Let's see if we can draw here and see how many of you can tell me which one is the enzyme. Which one is the enzyme? Let's draw right here, and let me see if you can tell me which one is the enzyme. Okay. Okay. Let's draw and see how many of you can tell me which one is the enzyme. All right. Okay. This is a graph. That's a graph. Okay. All right. Let me see if I can bring that a little bit in focus. Okay, I think you can see the black line at the bottom. No, maybe. Okay. Anyway, let me see if I can erase this a little bit more. All right, this is the graph right here. That's the graph. Okay, so now I want you to tell me which one is the enzyme. Okay, I have black and I have green. So now I'm going to make the same product. So these are the reactants. It's going all the way up, and then it's going to make whatever it's going to make. Okay, so over here is the product. Boy, I hope you guys. Okay. All right. So that's the black. All right. So the next one is I'm gonna use green. So this is gonna start from right here. That's gonna go right here. It's gonna produce the same thing. Notice both the black and the green both are ending up at the same place. They started up at the same, ending up at the same. Which one of these do you think is an enzyme? Is it a black or is it a green, and why? Okay, how many fish are the black? No hands up? Oh, two hands. Okay, all right. Tell me why. Tell the substitute teacher, or tell Miss K, why did you, Miss O, I'm sorry. Tell her why you think it's the black. Tell Miss O, why do you think it's the black? Remember, let me just remind you that enzymes lower activation energy. They don't, it's not a word, but I'm going to use it. They don't higher activation energy. They what? They lower activation energy. What do enzymes do? They what? They lower activation energy. So let's look at those two, the green and the black. Which one do you think is the enzyme? Great. So the green right here is the enzyme. How do we know it's the enzyme? Because look at that, activation energy is lower and they're producing the same thing. Both of them are the same, they end up in the same place. So they're producing the same thing. Okay? So the lower activation energy. All right? Are there any questions? So the lower activation energy. So let me bring it back in focus. Okay, there we go. So we know that the main job of two jobs actually. Enzymes are catalysts. Remember we said that enzymes are catalysts, and we also said that enzymes lower activation energy. All right, they lower activation energy, and they also act as catalysts. All right. Okay. What else do enzymes do? 3 enzymes are specific. We just finished explaining that. Okay, enzymes are specific. So let's go through that. Enzymes are proteins. Enzymes, catalyst. Enzymes are lower activation energy. and enzymes are specific. Fourth one, I'm not sure what question is this. Are enzymes destroyed? Well, to answer that question, let me ask you, your key. Anytime you use your key, is your key destroyed? Anytime you use your lock, is your lock destroyed? Now, if I'm telling you that enzyme works like lock and key, you answer that question. Are enzymes destroyed? Great answer. Enzymes are not destroyed. They are reusable. We can't destroy them because they have a job to do. If they're gone, guess what? Some of the food we eat will be useless. Okay? So majority of the time, enzymes are not destroyed. But let me ask you a question. Are you ready for this? What if you're at school? Your parents are at work. Is it possible that someone can pick your lock? Yeah. Somebody can pick your lock. Listen, when somebody picks your lock, they are messing up your lock. The keyhole, which is called the active site, is messed up. So guess what? When you go home and you're trying to put your key in that lock to try to open it, it won't work. What? Because it's messed up. You got me? Let me say it again. Your lock is like an enzyme. Your key is like the substrate. When you go home, hey, you can just take your key, put in your lock, open the door, no problem. But if someone picks your lock, they destroy that keyhole, your key will not fit there anymore. Why am I saying that? There are some times when the enzyme active site is destroyed. Yeah, destroyed. Listen very carefully to me. Most of you and none of you are at that, well, some of you are that age. But that's not a good example for me to use you. Let me use your parents as an example. If you're sick, if your temperature is like 105, 106, you better don't call your doctor. You better go to the emergency room right away. No, I'm so serious. I'm so serious. If you call the doctor and say, your mama is crying, your mother is crying, your sister is crying, he's got a high temperature, he's sweating, blah, 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 blah. You know what the doctor's going to tell you? Please take him or her to the emergency room right away. So why is it that high temperature is not good for you? Guess what? High temperature destroys the active site. Once the active site is destroyed, guess what? That enzyme will not work anymore. That enzyme cannot make and cannot break. Cannot make and cannot break organic molecules anymore. Guess what? If your enzymes are destroyed, and if you don't take care of it right away, you're going to sleep for a long, long time. I mean, I don't mean to laugh because this is serious. You have to take me very seriously. If your temperature is very high, our normal temperature is 98.6, and if it's getting to the 102, 103, 104, you should be concerned. Your parents should be concerned. Don't call the doctor. Don't try to take, you can take ibuprofen, but these other pain reducers. But you know what? Your best option to go quickly to the emergency room because your enzymes are being destroyed. So that should be another question on this worksheet. Why should you be concerned when your body temperature rises over 105, 106? Because most of the active site of your enzymes are destroyed and they will no longer be able to make or break organic molecules. Okay? All right. Another question is, What is one factor that can affect enzyme action? What is one factor that can prevent enzyme from doing its job? You got your key in your hand. The main job of your key is to open your lock so you can get in. What is one thing that can prevent you from opening the lock to your door? If it's destroyed, come on now. If the key is destroyed, you're gonna have problem getting in. You may be lucky to open it up, but if it's severely destroyed, you cannot get in. So when your temperature is getting higher and higher, yeah, it's destroying the active site. But if the temperature gets too high, that active site is going to be completely destroyed. Your enzyme will not work anymore. You hear me? So what is one factor that can affect enzyme action? I don't know what number that is. Write down high or very low temperature. That's right. If the temperature is too high, that enzyme going to be destroyed. Active site going to be destroyed. If the enzyme is very, very low, active site is going to be also destroyed. All right? So one factor that can affect enzyme action is the temperature. Okay? All right. So let's go to the other factor. Then we're going to draw diagrams. Okay? Let's go to the other factor. You're going to draw a diagram. I believe the video now is about 56 minutes, almost an hour. Thank you for your patience. Thank you for taking good notes. Thank you for listening. That's why I'm so proud of all my students. You guys are doing excellent. So thank you so much for listening and for taking. And those of you, obviously, now don't forget, Miss O. They have to turn in this worksheet at the end of class. If they fail to turn it in, the zero is theirs. So you need to congratulate them for earning a zero, okay? Okay, so here we go. Just to recant, just to review. One factor that can affect enzyme action: high, very high temperature, very low temperature. Our body temperature is about 98.6. Man, that enzyme loves that temperature, boy. It's doing its work just like you eat food, man. You ready? That's right. It's dancing all over the place. Anytime you eat the food, take it, chop it down, combine it, chop it down. Enzyme loves it. My blood temperature is high. That enzyme will begin to cry. So why me? Why me? Why am I in this environment? It's too hard for me. Somebody help. So you better help. And the way you help is go to the emergency room immediately. Another factor that can affect enzyme action is the pH. Lowercase p, capital H, pH. Anytime you hear me use the word pH, parenthesis, acid or base. Listen, there are some enzymes, you get me, that work perfectly in acid. They love acid. And guess what? There are some enzymes that love base. Listen carefully, please listen. Every single living thing have a range, a pH range, in which their cell can function perfectly. We humans, our range is what? What's our blood pH? Remember? Yeah, 7.3 to 7.45. That's our pH range. That's when the enzymes love that range. They love it. I mean, they love it. They are happy. But if that range go down to about 6, oh no, oh no, no. Your enzymes don't like it. And you know what that means, right? What happens when you take food, put in your mouth, don't like it? Spit it out because you don't like it. So when enzymes pH is not in the range where it normally likes, that enzyme gonna be destroyed. Let me repeat. Our pH is 7.3 to 7.45. If the pH goes up to base, like for instance, man, I don't really want to overemphasize, but I'm so serious. You're gone. Everlasting sleep. And your pH is 7.3, 7.45, your pH goes to 5. That's bad. Here's the good news, though. In all of this, here's the good news. And that would be another question. You have a mechanism in your body that helps you to regulate your pH. In other words, when your pH go up, you have that chemical that comes in. You say, not today, not today. Brings it back to the level where it's supposed to be. And if your pH go down to the acid, that chemical brings it back up to where it's supposed to be. And that chemical is called a buffer. B-U-F-F-E-R. What is it called? That's right, a buffer. So that'll be your next question. So the previous question is, what are two factors that can affect enzyme action and why? You just don't write, gotta give me an explanation. And the next question is, I forgot what the next question is. Okay, all right. The previous question is, what are two factors that can affect enzyme action? And the next question is, what is the human pH range? What is the human pH range? Okay, and what happens? So that question is there. That's why and what happens if the pH is above or below? And the other question is in there, why are buffers? So searching the worksheet for this question, why are buffers important for living things? Okay, why are buffers important for living things? Okay, now let's look at some examples of some diagram of how temperature can affect enzyme action. Whoops. How temperature, those are all my plaques, teacher of the year and all of that. And that work was given to me all the way back there. I'm not sure if you can see them. All right, here we go. I'm back in focus, but really I don't want to be in focus. Guys, give me about maybe about 15 more minutes, please. We're going to review all of this so you can get it. I hope no one is sleepy. It's kind of boring, isn't it? But hey, tell me something that's exciting. Everything that we do these days, it may not be boring for you, but some for others could be boring. Some of you, this lesson is exciting. Some of you is not. Hey, life goes on, but you're in class, so you have no option. Okay, here we go. Here we go. Okay, there you go. Please, everyone, pay attention. So now I want you to write. I cannot write it on my tablet that I have here because it's not visible. Really, because not really as that visible, so I'm going to say. So now I want you to go to a clean sheet of paper, and I want you to write this down. I want you to write down how temperature affects enzyme action. Okay, Miss O, please tell them. Let them write it. How temperature affects enzyme action. How temperature affects enzyme action. Okay. How temperature affects enzyme action. All right. So let me repeat it again. How enzymes affects enzyme action. Okay. Now I'll get you about 3 colored pencils, please. Don't use your colored pencil until I ask you to. Get about 3 colored pencils. Don't use your colored pencils until I ask you to. Okay, here we go. So now I want you to follow me. Don't use your colored pencil, use your pen or pencil. Draw a vertical line. and then draw an horizontal line. And the horizontal line, I want you to label it from 0 to 100 degrees Celsius. 0 to 100 degrees Celsius. 0 to 100 degrees Celsius. Okay, so this is 0 to 100 degrees Celsius. So there's 0, so there's 0, and the middle of it should be 50 degrees Celsius, see that? And then at the end will be 100 degrees Celsius, okay? So there's 0 to 100 degrees Celsius, okay? Okay, now on the vertical line, so this line over here, the vertical line, I want you to go from 100 to about 1,000, 100 to 1,000 substrate. Okay, so you start from 100 substrate, so there's a 100 substrate. So you go all the way to the top, the very top, and write down 1,000. So you start from 100 to 1,000. As you go up, that's great because it's telling you the enzyme is doing its work. As you go up, is great. Tells you the enzyme is doing its work. Okay, so you go from 100 all the way to 1,000. Okay, now use one of your colored pencils. So look what I'm doing. You start from the 0. So that's the 0 right here. Start from the 0. From 0 of your graph, you go all the way up. So now I want you to pay attention. So that's the 0 right here. So look, you're going up. I'm sorry. Start from the 0, go horizontal. It's what I'm doing. Straight line first. Now it start going up. It start going up. It start going up, and then it stop. And put a dot. So you start horizontal, and then it start going up, and then it stops, and then put. Okay. So that's it. So you see where it stops. Okay. So it starts from right here, it's like horizontal, and then it starts going up, and then it stops. Then after that, put that color pencil down. Put that color pencil down. Okay, next, reach for another colored pencil. Now you're going to go down. Okay, you were going up, so now you're coming down. So now you're coming down. Another colored pencil is coming down. It's coming down, and then you stop. Okay, it's coming down, stop. Don't go all the way to the bottom. Stop halfway, and then use your last colored pencil. Now draw a straight line. Okay, so here we go. It's going straight first, and then start going up, and then it stop. Okay, I told you to put a dotted line where it stopped, right here where it stopped. Put a dotted line. All right, and then it start coming back down. I say enzyme coming back down, and then now it's flat, straight. So now I want you to label A. So I label the A. At the very top, there's B. At the very top is B. Okay. That's B. And then the blue line coming down, that's C. And then the green flat line is D. You get it? Let's try it again. So you got A going up, you got a dot, that's B, where it stopped. Start coming back down, where it start coming back down to C, where it's completely straight, that's D, all right? Now the important one I want you to know is from the highest point, right at that dotted line, I want you to put a dotted line going down. So that's the best temperature for this enzyme. See the dotted line? That's the best temperature for this line. Right here as this dot, you write down OP optimum. optimum. So B, where you have that dot, is called the optimum. What optimum means? The best. Okay, so optimum means the best. All right. So this enzyme, this is an enzyme. This enzyme is in a certain environment, and we are observing to see what this enzyme is doing. Notice that A is doing very well. All the active sites are open. So look at that, almost 900. If you go straight down, it's almost 900 that 900 molecules it broke. But once it gets to the high temperature, once it passed, but mine it says 48. I'm not sure what your temperature says, but mine it says 40. Once it passes 48, guess what happened? That enzyme begins to come down. Once it starts coming down, it's no good. So this C is called denaturation. C, I'm going to spell it for you in a minute, is called denaturation. C is called denaturation. 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 So what is denaturation? Is when the active site has been destroyed. So that'll be your next question. Okay, what's denaturation? Where the active site has been destroyed. D, completely destroyed. Active site completely destroyed. So I will draw the graph, and you have to explain the parts of this graph. Okay, you need to know what A is, you need to know what B is, you need to know what C is, you need to know what's taking place in D. Okay. All right, so that's the end of the lesson for today. Your teacher, Miss O, will give you further instruction, okay? Your teacher, Miss O, will give you further instruction. Everyone has done very well, I would hope. So at the end of this lesson, after you fill in all your answers, make sure you give your answer sheet. If it's so you forgot, that's a 0. So I'm going to say it again. So if you don't listen to the video, then obviously you don't know, okay, what the expectations are. And the requirement is that you should have been looking at the video anyway. So there shouldn't be any excuse at all. You should turn your completely filled worksheets to me. If any part of that worksheet is not filled in, you don't get the full grade, and you may get a very bad grade, okay? So I hope everyone is doing very well. I hope everyone stayed alert and listened to the video, and I'll see you guys on Tuesday, all right? Okay. Bye-bye. You be good. This is Dr. Cisse.